Hey guys, hope you guys are doing well, and I'm sure your studies are going hard. First, I want to just say big hats off to you guys for doing paper two. You guys are doing amazingly well. I hope it went well for all of you guys. And yeah, welcome to my predicted paper three. So based on what's come up in paper two, and obviously what came up in paper one, I've obviously picked topics that haven't made an appearance yet. So bounds didn't come up. What else didn't come up? Vectors still hasn't come up, guys. It was in my paper one. I was like, okay, didn't come up paper one. It's gonna be in paper two. Didn't come up paper two. So I'm sure it will be in paper three. And it's not going to be as hard as the vector questions that I have done in paper one and paper two. So yeah, don't worry. But yeah, again, the link to this paper will be pinned in the comments, and it will be in the description, and it's also on my website as well. So just MathsWithDan.com. Go to predict the papers. You just go down to paper three, higher tier. So yeah, again, there's 21 questions, 80 marks. Wish you the best of luck for this paper, and yeah, for the actual paper on the 11th of June. And yeah, as recommended, do the paper first before watching the video. So if you stumbled across this video, make sure you stop it, do the paper and time conditions, and then come back. And yeah, that's pretty much it. Good luck, and yeah, let's get into the paper. Okay, so question one says a plane flew from Dual to Phuket. The distance the plane flew was 5,658 kilometers. The flight time was 8 hours and 12 minutes. Work out the average speed of the plane. So remember, speed is just equal to distance over time, isn't it? So speed is equal to distance over time. So the distance is 5,658. The time is 8 hours and 12 minutes. Now, we want it in kilometers per hour, don't we? So we need to convert that into hours only. So we've got 8 hours, which is fine. We need to now convert that 12 minutes into hours, don't we? So how do we go from minutes to hours? We just divide by 60. So I'm just going to divide that by 60, like that. 12 divided by 60 is just going to be 1/5, isn't it? So this here is the same as 1/5 of an hour, like that. Yeah. So therefore, the time, 8 hours and 12 minutes, is going to be 8 hours plus 1/5 of an hour, right? So I'll just put this in my calculator because why not? 8 plus 1/5 is equal to 41 over 5. So it's 41 over 5 in hours. So now we can put this here, can't we? 41 divided by 5. And so therefore the answer is going to be that divided by that. So I'll put in the calculator and see what we get. Now I've got that answer stored. There's no need for me to write again. It's going to be 5,658 divided by answer. This is equal to 690. So the answer is 690 kilometers per hour. And that's it for question one. Okay, so question two says in London, 1 litre of petrol costs 108.9p. In New York, one US gallon of petrol costs $2.83. One US gallon is 3.785 litres. £1 is $1.46. In which city is petrol better value for money? London or New York? You must show your working. Okay, so what we know as a fact, right, is how much petrol is in New York, right? One US gallon, all right, one US gallon is equal to $2.83. That is a fact, right? I'll put it in a box. So what I'd want to do is work out the cost of the petrol, right? In the UK, in London, right? And figure out how much it will cost in the US and then just correct to $2.83. So what I do know is that from London, 1 litre is equal to 108.9p. And then what I want to do now is figure out how much this is in terms of 1 US gallon, because we know that 1 US gallon is 3.785 liters. I'd want to work out the cost of sorry, not 785 liters, wouldn't I? Right? I'd want to work that out. So I'm gonna just do I'm gonna do 108.9 times by 3.785, isn't it? And that will give me that there. So that's going to be 412 point, what is it? 1865. Okay. Now remember, this from this sentence here, or this equation, this is the same as 1 US gallon, isn't it? So I can actually replace this. I can say that 1 US gallon, right, is actually equal to 412.1865p. Now, what I want to do here is figure out how much this costs in dollars and then compare it to the thing in the box. So how do we do that? Well, we've got this one. We've got £1 is equal to $1.46. All you're going to do to go from there to this is times by 1.46, isn't it? So all I'm going to do now is just times that by 1.46, isn't it? Because this is in pounds and I want it to go to dollars. So I'll just do that and put it into calculator. We're going to have, all I'm going to do, I'm going to just do answer times by 1.46. I'm going to do answer times by 1.46 and I get that number there. Yeah, so it's going to be equal to 601.792 blah blah blah. 79229, right? And this is in cents, isn't it? Right? Because this was in pennies. So what I want to do is just obviously get this into dollars by just dividing by 100. So I'll just do that. Divide by 100. And this gives us $6, doesn't it? $6 and 2 cents, essentially. $6.02. And then now we compare this to the actual price of 1 gallon in the US, which is $2.83. So you can see this is much more expensive, right? So the question says, in which city is petrol better value for money? It's better value for money in New York. They say New York is cheaper. And that's it. That's question two finished. Let's go to question three. So question three, just column vectors. It says, let me zoom in a bit. Okay. It says A is equal to 3, 4. B is equal to 5 minus 2. Find 2A minus 3B as a column vector. So, okay. Remember, we've got A is equal to 3, 4. Then what will 2A be equal to? Just times it by 2. It's just going to be 6 and 8. And then B is 5 minus 2. So 3B is just going to equal 15 minus 6. So therefore, 2A minus 3B is just going to equal 6, 8 minus 15 minus 6. Like that. And then now doing that, that's just going to be 6 take away 15. And that's going to be 8 minus 6, isn't it? So 6 take away 15 is going to be a minus 9. And then that's 8 plus 6, isn't it? Which is 14, right? Because two negatives make a positive. So the answer is going to be minus 9, 14. And that's question three finished. Okay, so question four says expand and simplify 3x bracket 2x plus 3 minus x bracket 3x plus 5 for 2 marks. So this one isn't too bad. So we're just going to just do this, the outside times the terms inside. So that's going to be 3x times 2x is going to be 6x squared. 3x times a 3 is going to be a plus 9x. And then I'm going to do minus x times a 3x is going to be minus 3x squared. And then I'm going to do minus x plus times 5 is going to be just a minus 5x, isn't it? So we've got 1 mark for expanding. We get the second mark for simplifying. So what can we collect? The x squared terms. 6x squared take away 3x squared is going to be a 3x squared. And then we're going to do 9 take away 5, which is going to be a 4, isn't it? So it's going to be plus 4x. So the answer is going to be 3x squared plus 4x for part A. Part B says make T the subject of the formula. P is equal to AT minus D. Okay, so firstly, all right, again, we've got P is equal to AT minus D. We first want to move the D over by adding it onto both sides. So I'm going to add on D on both sides like that. So it's going to become P plus D is equal to AT. And then, whoops, AT. And then now we need to get the T on its own. So we're going to divide through by the A, aren't we? Divide through by the A. So it's going to be P plus D divided by A is equal to T. So you can just say T is equal to P plus D divided by A. Perfect. Part C, it says given that W to the 5 times W to the N over W cubed is equal to W to the power of 10, work out the value of N. This is 2 marks. Okay, so firstly, what I can do is I can use my index laws to simplify the numerator. Remember, we've got W to the power of 5 times by W to the power of N. If I just look at that in isolation, we know that we add the powers together, don't we? So it's going to be W to the power of 5 plus N. And then now I can rewrite the question. So it becomes W plus 5, W to the power of 5 plus N over W to the power of 3. And this is equal to W to the power of 10. Now remember, what we can do from here is, you can actually do it two ways. You can either times by the W cubed to get on that side. Maybe I'll do that this time. I think it looks clearer that way. I'm going to times both sides by W cubed, actually, like that. So that way it becomes w to the power of 5 plus n is equal to w to the 10 times by w to the power of 3. And then obviously, again, we've seen that we add the powers together. So this is just going to be w to the power of 13. And then this is w to the power of 5 plus n. Now, if these are equal, right, it means that the powers must be the same, isn't it? So therefore, we can say that 5 plus n must equal to 13. So therefore, n is equal to 13, take away 5, which is just equal to 8, isn't it? So therefore, n is equal to 8. And that's it for question 4. Perfect. Let's move on to question 5. So, question 5 says we've got the universal set, and it's numbers from 1 to 14. We've got the set A, which are even numbers. We've got the set B, which are square numbers. And part A says complete the Venn diagram for this information. This is 3 marks. So with these types of questions, whenever you got these types of sets here and it's descriptive, what you'd want to do is actually write out what the actual values are. So this is even numbers. So we know it's just going to be 2, 4, 6, 8, 10, 12, and 14. Okay. And then square numbers. Well, what are the square numbers here? Well, it's going to be 1. 1 squared is 1. Now, just to be honest, to get the square numbers, just square root all of these, or tell yourself which numbers would square root nicely. 1 will, 2 won't, 3 won't, 4 will, 5 won't, 6 won't, 7 won't, 8 won't, 9 will. Like that. And that is it, isn't it? 10 doesn't, 11 doesn't, 12, 13. Yeah, this is it. 1, 4, and 9. Like that. Now that we've got our actual values that are in the sets, right? Now we can complete the Venn diagram. So what do? You always start off with the overlap. So I can see quite clearly that I've got a 4 in both of these. And I think that is the only number that appears in both. So there's only going to be a 4 in the middle. And then obviously the other numbers will go in the outer part of their set. So 2, 6, 8, 10, 12, and 14 would go there. And then 1 and 9 would go there, wouldn't it? And now that we've done that, remember, you need to do the numbers on the outside as well, don't you? So what numbers haven't we used? So what I like to do is just look at the numbers. I have used a 1. I have used a 2. I haven't used a 3. I'm going to leave that. I've used a 4. Can't see a 5 anywhere. Leave that. I can see a 6. Can't see a 7. We've used an 8. We've used a 9. We've used a 10. We haven't used 11, have we? I can't see 11. We've used a 12. I can't see a 13. No, sorry. I can't see a 13, so I'm going to leave that. And then I can see a 14. So all of the numbers that I haven't crossed out, so that's 3, 5, 7, 11, and 13, that would go on the outside, wouldn't it? So it's going to be like that. It's going to be 3, 5, 7, 11, and 13, like that. And that would be our complete Venn diagram, wouldn't it? So that will give you the 3 marks. Now, part B, it says a number is chosen at random from the universal set. Find the probability that this number is in the set A. This symbol means intersection, doesn't it? So A intersection B. So all we need to do is identify how many numbers are in the intersection. There's only one. There's a 4, right? So therefore, it's going to be 1 out of, let me put it here. It's going to be 1 out of, how many numbers are there? Well, it goes from 1 all the way to 14, isn't it? So there's 14 numbers. So the answer is just going to be 1 over 14 for the probability. And that is question 5 finished. So now let's go to question 6. Okay. So, question 6 says, a pond has 21,000 tadpoles. The number of tadpoles increases at a rate of 5% per year for 4 years. Calculate the total number of tadpoles at the end of 4 years. All right, so this one is just essentially compound interest, isn't it? So what is the formula? You have an initial value. I'm going to just write it here. Of initial value. Whoops, initial value. You times this by your multiplier, and I'll show you how to get it in a second. And then you do it to the number of years, like that. So what is the initial value? Well, there are 21,000 tadpoles, so I'm going to put 21,000 there. And the multiplier is just a percentage increase, isn't it? So it increases at a rate of 5% per year. So if I was to add that on to 100%, that, then it would be increasing by 105% each year, isn't it? So the multiplier is going to be just divided by 100, 1.05. You just get it as a decimal. That goes there. And then how many years is it for? It's for 4 years. So I'm going to put it to the power of 4. So therefore, I'm going to put this in the calculator and see what I get. It will be 21,000 to the power of 21,000 times I'll put the multiplication there even if it doesn't matter. 1.05 to the power 4. And this gives me that number there, but we're looking for a number of tadpoles. So what you want to do is you want to round this to the nearest whole number, isn't it? So therefore it's going to be 25. What was that? 25 5 to 6, isn't it? 6. And that is it. That will give you the 4 marks for question 6. Okay, so question 7 says the table shows the populations of 5 countries. So we've got the countries on the left, we've got populations on the right. Part A says work out the difference between the population of China and the population of Germany. Give your answer in standard form for 2 marks. Okay, so China and Germany, which one's bigger? Just look at the power. China is 10 to the 6. Sorry, China is 10 to the 9 and Germany is 10 to the 7. So 9 is bigger than 7. So China is bigger. So the difference would be China minus Germany, wouldn't it? So it's going to be 1.4 times 10 to the 9. Take away 8.2 times 10 to the power of 7. And I'll put this in my calculator first and see what we get. So 1.4 times 10 to the 9 minus 8.2 times 10 to the 7. And that gives me that number there, right? Which is 1318. And then how many zeros after that? 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. Now they want this in standard form, so that's very, very easy. All you're gonna do is obviously we've got this 1318 here. Put the decimal place in between the first and second digit. So it's gonna be 1.318 times by 10 to the power of, and then just simply count from the second digit. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the answer is 1.318 times 10 to the 9. And I'll put that there. Perfect. So that is part A. Part B. It says, given that the population of Fiji equals 1 over k times the population of Sweden, work out the value of k, give your answer correct to the nearest whole number for another 2 marks. Okay, so firstly, I need k, so the equation, right? Now, when I look at this, let me just zoom in a little bit more. I don't really like the fact that I've got 1 over k, right? When I'm dealing with algebra, I like k, right? I don't like 1 over. So what I would do simply is just times both sides by k. So what I'm going to do, I'm going to call population of Fiji F, and I'm going to call population of Sweden S, right? So the equation is F is equal to 1 over k times S. I'm going to times both sides by k. So I'm going to have kf is equal to S. And then that just simply means dividing both sides by f, that k is going to equal S divided by F. Population of Sweden divided by the population of Fiji. So all I'm going to do is just plug those in, and then that will give me K. And then obviously round it to the nearest whole number. So I'll do that here. So what was the population of Sweden? It was 9.9 times 10 to the 6, isn't it? 9.9 times 10 to the power of 6. And then the population of Fiji is 9.1 times 10 to the 5. 9.1 times 10 to the power of 5. And then put this into the calculator, what do we get? Let's see. So 9.9 times 10 to the 6 over 9.1 times 10 to the power of 5. And that is equal to that number there, 10.879, blah, blah, blah. But, whoops, let me put the dot, dot, dot at the bottom. And they want this to the nearest whole number, which is just going to be 11, isn't it? So k is equal to 11. And that is question 7. Now let's go to question 8. So question 8 says, the diagram shows a solid cube placed on a horizontal table. The pressure on the table due to the cube is 4 newtons per centimeter squared. The force exerted by the cube on the table is 576 newtons. Show that the total surface area of the cube is less than 1000 centimeters squared, and we have the formula for pressure. It's force divided by area. Now, they've told us that the cube is placed on a horizontal table, right? So the pressure is just going to be coming from this surface, isn't it? Right, so what I can do is I can calculate the area of this surface, because this is the surface which makes contact obviously with the table, right? So what I'm going to do is I'm going to use that formula, right? What do I know? I know that the pressure is 4, so I'm going to write P is equal to 4. I know that the force exerted by the cube on the table is 576, so that just gives further confirmation that it's going to be one surface that we're going to look at, right? So, and no, sorry, the force exerted on the table, that's a force. Change that to an F, right? So what I can do now is, well, the formula is P is equal to F divided by A. If I rearrange this, because I've got P and F, I want to make A the subject. I'm going to say A times both sides by A divided by the P is just going to be F divided by P, like that. So what I'm going to calculate here is the area of that yellow surface, right? The one that makes surface with the horizontal, the one that makes contact with the horizontal table. So that's going to be, A is going to equal 576 divided by 4, isn't it? So I put it to the calculator, see what I get. 576 over 4. This is equal to 144, right? Perfect. And this is 144 centimeters squared. Now, this is one surface, right? So I'm going to write one surface. Or let me write one face, actually. One surface face, same thing, but I'll just say one face. One face is equal to 144 centimeters squared. The total surface area, remember, this is a cube, isn't it? So each of the faces are going to be the same area. So the total surface area is going to be 6 faces. So let me write TSA for total surface area. This is going to be equal to 6 faces, isn't it? So we're just going to times that by 6. So 144 times 6, this is equal to 864, isn't it? Centimeters squared. And it says show that this is less than 1,000. Well, that is less than 1,000, isn't it? So you say 864 is less than 1,000. And that's it. Done. That's question 8 finished. Okay, question 9 says some people were asked if they wanted a new phone. 65% of the people said yes. 75 of the people who said yes wanted a phone with a long battery life. What percentage of the people asked said they wanted a phone with a long battery life? Okay, and this is how many marks? This is 2 marks. Okay, so what we do know is that there are 65% of people that said yes. I'm going to write 65% is equal to a yes. Now, the second sentence says 75% of the people who said yes wanted a phone with a long battery life. So when you think about it, right, this is 75% of the people that said yes, which is actually 65%. So the way I translate this sentence is just the same thing as just saying, well, it's just 75% of the 65%, isn't it? Right? Now, how do we calculate this? Well, this is just multipliers and multiplication, right? So that is as a decimal 0.75. We know that we're doing 75% of this, so we're going to change it to a times. And then this is just 0.65. So the answer is just going to literally be 0.75 times 0.65, whatever that is. Put this in my calculator, 0.75 times 0.65. This is equal to 48.75, isn't it? As a percentage. Let me just write this as a decimal first. What is it? 0.4875. And we want this as a percentage. So I'm going to times by 100, which is going to be 48.75%. Perfect. And that is it. That will give you the 2 marks. Okay. So that's question 9. Okay, so question 10 says Sydney invests £9,000 in an account for 1 year. At the end of the year, interest is added to his account. Sydney pays tax on this interest at a rate of 20%. He pays £36 tax. Work out the percentage interest rate for the account, and this is for 3 marks. Okay, for us to be able to work out the percentage interest rate, we need to figure out how much interest Sydney's getting in this 1 year, right? Now, how do we do that? We know that Sydney pays tax on this interest at a rate of 20%, and we know how much the taxes is £36. So what we can say is that this 20% here has to equal that £36, isn't it? Right? It's going to be 20% of the interest. So what I can do is say 20% must equal 20% must equal the £36. And well, 100% is going to be the actual interest that Sydney gets in this 1 year, isn't it? So I just need to calculate what 100% is, and you do that just by times on both sides by 5, aren't you? So times both sides by 5. So I'm just going to do 36 times by 5, which is going to be 180, right? So that must mean that Sydney gets £180 interest, isn't it? And then obviously has to pay £36 on it. Now, the percentage interest rate, how do we calculate that? Well, it's just a percentage of 180 out of the amount of money that's in the investors, which is £9,000. So we're going to just do, all right, percentage interest rate. This is just going to equal the money that Sydney gets in interest, which is 180, divided by the initial amount that you invested, which is going to be that, and you're just going to times this by 100, aren't you? So it's just going to be equal to, put this into the calculator. It's going to be, whoops, too many fractions. 180 over 9,000 times 100. And that is equal to 2. So the answer is just 2%. And that is it. That's question 10 finished. Okay, so question 11 says the table shows information about the times in minutes that 80 patients had to wait to see a doctor. So we've got the times in minutes on the left, frequencies on the right. Part A says complete the cumulative frequency table below. Okay, and this is only 1 mark. So remember, cumulative frequency is like a running total. Your first number is going to always be the one at the start, and the next one's going to be adding on the second number. So 7 plus 10 is 17. And then we're going to add on the next number, which is going to be 17 plus 15 is going to be 27 plus 5, which is 32. And then 32 plus 32, I know that's 64. And then 64 plus 16 is 80. So that will give you the 1 mark. And then now part B says on the grid opposite, draw a cumulative frequency graph for your table. So the grid is on the next page. So what I'm going to do is we've got the grid there. I'm going to actually just screenshot this table here. And then I'm just going to use that. So I don't need to keep going up and down. And I think that's very efficient. So doing that. Okay. So what you want to do is you essentially want to plot these like coordinates. You're going to plot the cumulative frequency numbers with the ending of your class width. So I'm going to plot 10 and 17. So 10 on the time, which is there. Sorry, not 10, 17, 10 and 7. 10 on the time, 7 on the frequency. So that's going to be 5, 6, 7. It's going to be over here like that. That's going to be the first one. Let me just do it a bit neater, just so it's super, super clear. It's going to be right here like that. I mean, there's not much difference to be honest, but anyways, okay, that's one. And then I'm going to do 17 and 20. So 20 is there. 17 on the frequency is going to be 3 below 20, which is going to be 19, 18, 70 is going to be right there like that. And then the next one's going to be 32 and 30. So 30 here, where's 32? That's just going to be 2 above 30, which is going to be 1, 2 over here. And then next one is going to be 64 and 40. So 40 on the time, 64 on the cumulative frequency, which is going to be that's 60. 1, 2, 3, 4 is going to be over here, isn't it? I need to go up a bit. Try again. It's going to be right here, just one below 65. And then the last one is obviously going to be 50 and 80. So 50 on the time, 80 there. Here, isn't it? Like that. And then all you want to do now is essentially just draw a smooth S through those points, isn't it? So I'm just do that here. It's a bit hard with this graphics tablet, guys, this pen that I've got, but I'm going to try my best. I'm sure you guys will be able to do it much better than me. So it's going to be like that. I think that's okay so far. It's not the worst. And, you know, let me try again. We may be here for a while, guys. Okay, so I think that's okay. And then I'm going to just curve it down like that. And then I'm going to just do a smooth one like that. And then I think, hold on, that one, a bit too thin. Try again, like that. And then we're just going to curve it like that. That's the best that I can do with this software. Let me try the last bit again, actually. I think that's doable, right? Okay. So that's done. Part C says use your graph to find an estimate for the median. Okay, the median is your middle value. The frequency, remember, is 80, isn't it? Half of 80 is 40. So you're going to go to 40 on your cumulative frequency and figure out what that time represents. So it's going to be there. So 40 is going to be, I'm doing a different color. It's going to be here, isn't it? That's 40, like that. And then that takes me to right here, isn't it? Which approximately is going to be like that essentially, which is going to be 31, 32, 33, maybe 32.5. There's always going to be a range for this anyway, so I'll just say 32.5. And then part D is use your graph to find an estimate for the interquartile range. Now remember, interquartile range is the upper quartile minus the lower quartile. Upper quartile is 3/4 of the data, which is going to be 3/4 of 80, which is going to be 60. So I'm going to do one there. So I'm going to work out what that is over there. So like that, which is right there, and then go down there. Okay, whoops, it's going to be here, isn't it? This value over there, which is going to be 1 less than 40. That's going to be 39. And then the lower quartile is 1/4 data. A quarter of 80 is 20. So I'm going to go to 20, which is going to be over here. That, and what value for the time does that give me? Gives me this number right here, which so happens to be 22. Yeah. So we now have the upper and lower quartile. The interquartile range of the times is going to be the difference between those two numbers, isn't it? So it's going to be 39. 39 take away 20, 2, which is just going to be 17, isn't it? So the answer is going to be 17 minutes. And that is it. That is it for question 11. Okay, so question 12 says solve x minus 5 all squared is equal to 7. Give your solutions correct to 3 significant figures. And this is only 2 marks. Now, a couple of things here. I've got this power of 2, right? So straight away, I should be able to identify what type of equation I have in front of me. And because it's a power of 2, if I was to expand that, then the x term at its very highest would be a power of 2. This would be a quadratic equation. Now, what you want to do, there's 2 ways to do this. I'm going to show you the quick way, and I'm going to show you a way that maybe some of you may do, just in case you're not aware of this way. You maybe are, but anyways, I'll do both just to be thorough. So firstly, what I would do, I've got x minus 5 all squared is equal to 7. Now, imagine this was an x minus 5. Imagine it was just x squared. Then what you guys would do, and rightly so, would just square root both sides, isn't it? Plus or minus. Now, you're going to treat that x minus 5 as if it's just an x. You're going to do the exact same thing. So I'm going to rub this out. If I square root both sides, then it's going to be x minus 5 is going to equal the square root of 7 with a plus or minus, isn't it? And then now to get the answer, remember, we're looking for x. It's just going to be x is equal to, that's a negative 5. I'm going to put it onto the right by adding it, but I'm going to put it in the front, so it's positive, and then plus or minus root 7. So you have 2 answers. You have either x is equal to 5 plus root 7, or you have x is equal to 5 minus root 7. And these two are going to be answers. So I'll put this into the calculator, see what we get for both. So 5 plus root 7 is equal to 7 point, what is it, 3 significant figures? 7.65, that's going to be one answer. 7.65 to 3 significant figures. Or x is going to equal, and then we're just going to do the opposite of that, take it away. Like that. And then that is going to equal 2.35, isn't it? 2.35. Okay, so this is the answer here. Now, this was quite quick, isn't it? Now, what some of you may have done, which is absolutely not a problem at all, is you may be thinking, well, I've got a bracket here. I will want to expand it. So, whoops, what I'm going to do is I'm going to expand it and see what I get. So, I'm going to have x minus 5. X minus 5 is equal to 7. Expanding that is going to be x squared. I'm going to have a minus 5x and then another minus 5x. Plus 25 is equal to 7. And then simplifying, I'm going to have x squared minus 10x plus 25 is equal to 7. And then it's going to be x squared minus 10x. And then taking away the 7 is going to be 18, isn't it? And this is going to equal 0. So I've got in this form here, and then what you may be thinking to do is just apply the quadratic formula, which is absolutely fine as well. So what would that be? Remember, the quadratic formula is going to be x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. And then obviously identifying your a, b, and c. Remember, this is a 1 here. It's going to be a is equal to 1, b is equal to minus 10, and c is going to equal 18. So remember, if you want to use this way, make sure you always write it down, right, clearly. So I'll do it here. Write down your a, b, and c, I mean. So it's going to be x is equal to minus, b is negative, so it's going to be minus 10, plus or minus the square root of minus 10 all squared, minus 4 lots of a, which is 1, and c, which is 18. It's going to be all over 2 lots of 1. And you could put this into a calculator, change the plus or minus, you're going to get the same thing, and I'll just show you. So doing that, let me do it. So it's going to be fraction, and it's going to be, that's going to be a minus. That's going to be positive term. I'm going to just write it super clearly, exactly the way I've written it. Put the plus first, and then going to be minus 10 all squared, which I know is 100, but again, I'm going to put the squared around it. Minus 4, and then it's going to be 18, isn't it? Like that. And then all over 2 times 1. You see, you get 5 plus root 7, the exact same thing we got before. And then obviously, if you want to change that to a minus, you get the exact same thing, right? So therefore, this is just 5 plus or minus root 7. but you didn't have to do all of this. You could have just literally squared it from there and then added on the 5. So I'll definitely recommend doing this in case this comes up on Tuesday. It's the 11th of June, isn't it? Tuesday the 11th, I believe. Or is it Wednesday? Oh, anyways, it's the 11th of June, whatever day that is. But yeah, if that comes up, then I would recommend doing it this way. But that's not to say that you can't do it this way as well. So if you want to expand it and use a quadratic formula, you're more than welcome to. So yeah, our final two answers are going to be x is equal to 7.65 or x is equal to 2.35. And that'll give you the 2 marks. Okay, so question 13 says the frequency table gives information about the number of mice in some nests. So we've got the number of mice on the left, we've got the frequencies, which are the nests on the right. And it says the mean number of mice is 7. The mean number of mice in a nest is 7. Work out the value of x. Okay, and this is 4 marks. So we need to calculate the mean, right? And the mean, remember, is just the sum of all of the values divided by the total amount. Now, how do we calculate the sum? Well, what does this mean contextually? What we're saying here is that there are 5 mice, or there are 5 mice in 4 nests, and there are 6 mice in 13 nests, and so on and so forth. So what you'd want to do is, well, you would want to add the number of mice here 4 times, which would be essentially the same as multiplying them, isn't it? So what you're going to do is you're going to do another column where you're going to multiply these together. And this is going to give you the sum of the respective rows, isn't it? Right? Number of mice, which are 5, and there is 4 in the nest. So that's going to be a 20, and then so on and so forth. So I'm going to just do another column like this. And I'm going to just do it number of mice. Whoops. What I'll do actually, I'll write m times f, the mice times the frequency, and that will give us the sum of each of these. So then I'm going to put it in and see what we get. Now, what do I know without a calculator? Well, I know that 9 6s are 54. I know 8 x's are 8x. And I know that 5 4s are 20. And then the others, I'm going to do a calculator. I'm going to use a calculator. So it's going to be 6 times 13, which is equal to 78. And then 7 times 16, isn't it? Which is 112. So what I can now calculate is the sum of everything, isn't it? By adding all of these together. So what I'm going to do is in my calculator, so actually let me actually get the mean first. Let me write a formula for the mean. The mean is going to equal the sum, right? The sum of the m times f column, right? Divided by the frequency, wouldn't it? That would be the answer to the mean. And we know that the mean is 7, by the way, they've told us. So we're gonna form an equation to calculate what x is. So what I'm gonna do is I'm gonna calculate the sum of m times f by adding all of these together. So what I'm gonna do in my calculator is I'm just going to I'm gonna put every number in except for the 8x, isn't it? And I'll put that on after. So 20 plus 78 plus 112 plus 54. That is equal to 264, isn't it? So it'll be 264 plus that 8x, like that. So that would go there. So 264 plus 8x, like that. And then the frequency is just going to be the sum of all of these, isn't it? Now, again, this is going to be in terms of x2. So what I'm going to do is I'm going to add all of these apart from x. So it's going to be 4 plus 13 plus 16 plus 6, which is going to be, let me just make sure I put it correctly. That's fine. It's going to be 39. So it's going to be 39 plus x there. And then that will go there plus x, and then this is going to equal 7. Now I've formed an equation. I can now solve it to figure out what x must be. So what I'm going to do is I'm just going to grab this and put this here, so there's more room. So put this there. Okay, now what do I do to solve this? So I'm going to firstly multiply the denominator. So it's going to be 264 plus 8x is equal to 7 times 39 plus x. And what is that equal to? Expand that bracket. What are 739? 7 times 39 is equal to 273. So 273 plus 7x on the right, and then 264 plus 8x on the left, right? So all I'm going to do now is I'm going to move that there, and I'm going to move that there, aren't I? So I'm going to have 8x minus 7x is going to equal 273 minus 264. 8x minus 7x is just 1x, that's going to be an x. And 273 minus 264 is just 9, isn't it? So therefore x is equal to 9. That's it. And that will give you the 4 marks. Okay, so question 14 says, OAB is a sector of a circle with center O and radius 7 centimeters. The area of the sector is 35 centimeters squared. Calculate the perimeter of the sector. Give your answer correct to 3 significant figures. Okay, so perimeter. Firstly, well, what is the perimeter? Well, the perimeter is going to be all of the sides added together, isn't it? So it's going to be this side, which is 7, plus that side, which is 7, plus this side in a blue, which we don't know, but this is the length of that arc, isn't it? So the answer, let me write arc here. This is the arc length right here. The answer for the perimeter straight away is going to be 7 plus 7 plus the length of the arc, which I don't know. So I'm going to just say P is equal to 14 plus the length of the arc. Now, how do I calculate that arc? Well, we need to remember the formula for arc, isn't it, right? The length of an arc, and there's actually two. There's the length of the arc formula, and there's the area of a sector formula as well. So this hasn't come up yet, so make sure you remember them. I'm going to write both of them because we're going to actually need both of them, to be fair. So I'm going to write arc length. Arc length is going to equal, if you've got a sector and then you've got this angle here, I'm going to call it theta. It's going to be the angle theta divided by 360 times by the circumference, which is going to be 2 pi r. Or remember, you could write this as pi d. I'm just going to do 2 pi r because I've got the radius. And then the length, or so that's the arc length. Now the second formula is the area. Area of sector is going to be equal to the angle divided by 360 times by the area of a circle, which is pi r squared. And essentially, this is just calculating the fraction of the circumference and the fraction of the actual total area of the circle. That's all these formulas are. So remember what we're trying to do. We're trying to calculate the length of that blue side there, which is the arc. Now, the formula for the arc obviously depends on the angle theta. So we need to be able to calculate that angle first before we can even figure out what the arc is. Now, how do we go about calculating that angle? They've given us some information. They've told us that the area of the sector is 35 centimeters squared. Now, whenever you have these types of questions where they just give you a statement, right? The area of this is that, and so on and so forth, you can use that to form an equation, right? Because with that one, well, I know that the area of a sector formula is right here. It's going to be theta over 360 times by pi, and then the radius in this case is 7, isn't it? So 7 squared, like that. And then we know that this is equal to 35. So that is our equation formed. We can now use this to calculate what theta is. And then once we know theta, we can plug it into the arc length formula, add it to 14. You're done. So let's go ahead and do that. So continuing is going to be that one there. I'll do it right here. It's going to be theta over 360 times by 7 squared is 49. 49 pi is equal to 35. And then to get theta, what I'm going to do is I would divide by the 49 pi with the 9 times by 360. So it's going to be theta is equal to 35 divided by the 49 pi times by the 360. And this will give me the angle here. So I'll put this into the calculator to see what I get for it. So it's going to be 35 over 49 pi. Whoops, I need a pi. Times by 360. And that is equal to 81.85, right? So 81.85 degrees and so on and so forth. Now, I don't want to actually calculate this exactly yet. I don't want to round yet because it's not my final answer. So what I can now say is that the angle there approximately is 81.85 degrees. The question asks us to calculate the perimeter. And remember, to calculate the perimeter, we need the length of that blue side, which is the arc. We can now find that now because we know what theta is. So what I'm going to do now is I'm going to copy this one more time and then plug in the angle, aren't I? So it's going to be over there. And then now I know what the angle is. I can say then that this is just going to equal 81.85 dot 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 over 360 times by 2 pi r, isn't it? Right? And the radius we actually know is 7. So I can actually calculate what this is now. So I put this in my calculator. I've got that number stored. So there's no need for me to write again. It's just going to be answer over 360 times by 2 pi and then 7, isn't it? Like that. And then that gives me just 10, right? So therefore, this is just equal to 10, right? And it's in centimeters, isn't it? So therefore, I know what that is. That is just 10 centimeters. So therefore, the perimeter is going to be 14 plus the length of the arc, which is just 10, right? Which is just equal to 24. So it's just going to be 24 centimeters to 3 significant figures. And that's it. Finished. I'll put it here as well. 24 centimeters. maybe 24.0 because it said 3 significant. But yeah, that's it. Finished. Okay, so question 15 says L, M, and N are points on a circle, center O. QMT is the tangent to the circle at M. Part AI says find the size of angle NOM and give a reason for your answer for 2 marks. So firstly, what I'm going to do is mark the angle in question. So NOM is this one at the center right here. Now, when you're doing circle theorem questions, right, what you want to do is have all of the circle theorems memorized in your head, right? I always tell this to my students. Make sure you have them summarized in your head and you're going to be thinking of which circle theorems are applicable based on the question. Now, the fact that I marked this angle here, which is at a center, is making me think of the circle theorem, which is like this, isn't it? You've got a circle like this, and you've got this kind of like what do you call this, like a kite thing maybe, and then this angle here is 2x, and then this angle here is x. The angle at the center is always twice the angle at the circumference, and we've got the angle at the circumference here, which is 27. This is going to be 54. Now it doesn't look like it, however this is like a special case of it, and if you guys go to my walkthrough that I did for GCSE Edexcel paper 1 of the June 2023, it's on my channel. Have a look for it. It's on paper 1. The exact type of question comes up as well. And I've actually put a graphic on that one. So definitely check that out so you can see what I'm talking about. But essentially, this point M here, imagine this point M could move. And let's say M was here, for example. Let's say M was right there. Then essentially, it would just literally just be something like, or maybe that's not great. M would be there. And then that would be like that, isn't it? Kind of be like that, maybe. It's a bad drawing, but definitely have a look at that walkthrough. So June 2023, paper 1, the exact type of question comes up in my walkthrough, and I've actually put a graphic in the video as well, so definitely check that out. But this is just a special case of it. So this is definitely 54 degrees. And obviously the rule is give a reason. The angle at the circumference is twice, sorry, the angle at the circumference is half the angle at the center, or the other way around. Which make sure that makes sense. The angle at the circumference is half the angle at the center, which is the same as saying the angle at the center is twice the angle at the circumference. And normally that writing it the other way around, but yeah, both of these mean the same thing. So that would be your answer. Now, part B, I says find the size of angle NMQ, which is going to be NMQ is going to be this one over there, like that. Now, which circle theorem is applicable here? Well, again, this is a tangent right here. I've got an angle over here, and I've got a triangle with all points on the circumference. So you've got to be careful. This one here, isn't it? Right? All of the points of this triangle is on the circumference. So what we can use is the alternate segment theorem. These two are going to be the exact same, isn't it? Based on the alternate segment theorem. So therefore, I'm going to just write this is going to be 27 degrees as well. And the reason is going to be the alternate segment theorem. Theorem. And that's it. That will give you 4 marks. Okay, so question 16. It says the curve C has equation y equals x squared minus 5x plus 9. The line L has equation y minus 3x plus 7 is equal to 0. Show algebraically that C and L have exactly 1 point in common. And this is how many marks? This is a 4 marker. Okay, now, when you do these types of questions, it's algebra. What specifically in algebra? Show that C and L have exactly 1 point in common. Well, what does that mean geometrically? We've got a curve and a line, right? If they have only 1 point in common, that means they only meet once, which means they only have 1 point of intersection, right? So I'm going to write here, we have 1 point of intersection. So now that we've figured out that it's a point of intersection, how do we find points of intersection algebraically? Well, we just solve equations simultaneously, right? So this is a simultaneous equation. Now, what type of simultaneous equation is it? Well, this top equation here, well, what type is that? This is a line, right? This is a linear equation. The power of x at its highest is a 2. This is a quadratic. So this is a quadratic simultaneous equation. So what you want to do is essentially write them both out. So I've got y equals x squared minus 5x plus 9. and I want to solve this simultaneously with y minus 3x plus 7 is equal to 0. Now, since this is a line, I'm actually just going to rewrite this. I'm going to move these two to the right, aren't I? And that will be, I'll do it here. I'll write C here for the curve, and then L here is going to be equal to 3x minus 7, isn't it? Now, to solve this simultaneously, well, this is in a different form. There's normally it's stuff like this. X plus y squared is equal to, I don't know, 25, and then you've got maybe y plus x is equal to 7. And then you can rearrange this one to say, well, x equals 7, take y, and then plug that in there, or rearrange it to make y the subject as well. Now, this one here, which we want to solve it simultaneously, well, when they are intersecting at that point in common, the x's and the y's are the same, isn't it? So since this is y is equal to this and y is equal to that, at the point of intersection, the y's are going to be the same. So what I can actually do is just essentially equate them like that. 3x minus 7. Now, algebraically, if it has one point in common, then there's only going to be how many solutions to this equation? There's only going to be one solution. So what we want to do is use algebra to show that there is only one solution. So when you're doing these types of questions, right, just think about it logically. There's only one point in common. We need to show that. So what you should be thinking in your head is, when I solve this equation, I should only get one answer. And if you do, then you know that you're on the right track and you're probably going to be correct. So how do I solve this? It's a quadratic equation. You want to move everything from right to left. So I'm going to do x squared minus 5x, and I'm going to minus that 3x, and then I'm going to do plus 9, and I'm going to plus that 7, aren't I? Which is going to equal 0. And then this is going to be x squared minus, that's going to be an 8x, and then 9 plus 7 is 16 is equal to 0. Now, how do I solve this quadratic? Well, what we can do is see if it factorizes, right? So if I attempt to factorize that, well, I need two factors of 16, which are going to add to make minus 8. It's going to be 4 and 4 if it was positive, but it's because it's negative, it's going to be minus and a minus there. So what I'm going to do is I'm going to say I've got x. I'm going to have two brackets like this. It's going to be x there, it's going to be x there, and then it's going to be just minus 4, minus 4. This is the exact same root, isn't it? Right? You can actually just think of this as x minus 4 all squared, like that. And then square root, it's going to be x minus 4 is equal to 0. There's only one answer here, right? X is equal to 4. Yeah? So the fact that we've only got one value of x, right, tells us there's only one point in common. But what you can do, just to be super clear to the examiner, you may as well find the coordinate of y, the y coordinate, I should say. And we can plug this into either one. I plug it into the line because it's easier. So if y is equal to 3x minus 7, that means that y is going to equal 3 times 4 minus 7, which is going to be 12 take away 7, which is just equal to 5, isn't it? So therefore, the coordinate where they intersect is just 4, 7. So you could say, therefore, 4, 7 is only one point in common, right? And that will be it. That will give you the 4 marks. So you've solved it. You've shown that there's only one point in common, right? It's essentially one point of intersection. If there were more, then you would have more. You'd have one more solution, isn't it? There's only going to be two at most, but we only got one. So that proves that there's only one point in common. And that's it. Finished. So question 17 says, here are the first 6 terms of a quadratic sequence. 15, 19, 25, 33, and 43. Find an expression in terms of n for the nth term of this sequence. And this is a 3 marker, I believe. Okay, so quadratic sequences. There's actually 2 ways to do this. I'm going to do both ways. I'm going to do which I believe to be the most conventional way, and I'm going to do another way, which is actually quicker. But you guys can let me know which way you do in the comments. So firstly, what you want to do, I'm going to write out again. I've got 15, I've got 19, I've got 25, 33, and 43. I'm going to find the difference between these numbers going to be a 4 there. Difference between this is going to be a 6. And the difference between that is going to be an 8. And the difference between that is going to be a 10. Now, this difference is going up, right? I'm going to find the next difference, which is going to be constant. And that's going to be a 2. Like that. And then once I know that this second difference is constant, it means that it's a quadratic sequence. And what I do now is that number, 2, the second difference, which is constant, I'm going to divide it by 2. 2 divided by 2 is 1, right? So what I'm going to do is I'm going to multiply this number here by n squared, like that, which is just going to be n squared essentially. And then what I'm going to do is figure out the first couple of terms of this sequence. So it's just the square numbers, isn't it? Which is going to be 1 squared, which is 1, 2 squared, which is 4, 3 squared, which is 9, 4 squared, which is 16, and 5 squared, which is 25, and so on and so forth. Now, once I've got this, by the way, this n squared is actually part of your answer. So it's going to be n squared plus blah, 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 right? So that's part of the answer, the first part. Once I've got this sequence, what I'm going to do is I'm going to write the original sequence again. So it's going to be 15, 19, 25, 33, and 43. And I'm going to write this underneath. It's going to be 1, 4, 9, 16, and 25. And I'm going to take these away. Taking this away is going to be 15 take away 1 is 14. That is going to be 15, like that. That is going to be a 16, isn't it? That's going to be 17, and then that's going to be 18, isn't it? Like that. That is a 4, by the way. Look, my 4s and 9s look the same. I've seen you guys say that in the comments. That is a 4. Like that. Perfect. Okay. So we are here now. What do you do now? Once you've got this here is always going to be a linear sequence. And what you want to do now is get the nth term of this linear sequence here, right? And then add it onto your n squared, and that is your answer. So it would be the nth term. This is an arithmetic sequence. So it's going up in ones. So it's going up in ones like that. So because of that, you know it's going to be a 1n. And then you ask yourself, what would be the term before the first, right? It would be a 13, wouldn't it? If I was to go back by 1. So therefore, it's just going to be 1n plus 13. And now, obviously, that's just n plus 13. So now, these two together make your quadratic sequence. So the answer is actually just n squared plus n plus 13. And that is one way to do it. Now, there's another way to do it, and it involves these here. So what I'm going to do is I'm actually going to grab these here. So grab this here, and I'm going to put this there. Now, once you get to this part and you've done the first couple of differences, right? You're going to label this part here. You're going to label this 2a. You're going to label this 3a plus b. And you're going to label this a plus b plus c. And all you need to do is make each of these equal, right? And then you just solve them. So firstly, I'm going to solve the bottom. When you're going to start from bottom and go up, it's going to be 2a is equal to 2, like that. And that's going to equal 1, like that, right? Let me write a is equal to 1. And by the way, what you're doing here, essentially, these letters a, b, and c, right? Let me write a is equal to 1. It's going to be your coefficients of the quadratic expression. So it's going to be an squared plus bn plus c. Yeah? And when we find a, b, and c, that will give us the quadratic expression. So let's see if we get the same thing. So yeah, 2a is equal to 2. That means a is equal to 1. So I know what a is. Now I know what a is, I could find the next one. I could go up. 3a plus b is equal to 4. I know that a is 1, so it's going to be 3 lots of 1 plus b is equal to 4, which means that 3 plus b is equal to 4. So that just means that b is equal to 4 take away 3, which is 1 again. Yeah? So a and b are both 1. Now I know where a and b are, I could find c by making this one equal to 15. So a plus b plus c is equal to 15. So I'll do that here. A plus b plus c is equal to 15. I know that a and b are both 1, so it's 1 plus 1 plus c is equal to 15. So 2 plus c is equal to 15. So that means that c is just equal to 15 take away 2, which is 13. So now I know what a, b, and c are. A was 1, b was 1, c was 1. Remember what we said? It was an squared plus bn plus c. So let me just write here again. A equals 1, b equals 1, and c equals 1. So c equals 13. So therefore, it's going to be n squared, 1n squared, plus 1n plus c, which is 13, like that. And that is exactly what we got here, isn't it? So you can see that it works. So yeah, there's 2 ways to do it. Let me know in the comments which way you guys are taught in school, which way you guys prefer. I've normally typically teach the one on the left, but I did see this one maybe a couple of years ago, and I think it's quite good. It's quite efficient. So yeah, let me know in the comments. And yeah, that's question 17 finished. Okay, so question 18 says, make y the subject of the formula x is equal to 4, bracket 2y minus 5, divided by 4y plus 3, and this is a 4 marker. Now, these types of questions are the trickier types of changing the subject, whereby you have the thing that you're trying to make the subject appears twice, and it's a fraction here. What do you want to do? Firstly, you always want to get rid of any fractions, right? Just because when you have fractions, you can't move things over. You can't move things from left to right. So the first step I would do is multiply both sides by the denominator, 4y plus 3. like that. Hold on, let me just make this, let me move this up a bit, just so it's in line with the multiplication. And on the same side as well, on the right side as well. So it's going to be like this on both sides. So now it's going to become x multiplied by 4y plus 3 is equal to 4 and then 2y minus 5. Now, we've got no fractions anymore. We need to move things around. So we now need to get rid of the bracket. So you're going to expand both sides. So if I do that, it's going to be 4xy plus 3x is going to equal 8y minus 20, isn't it? Now, the thing that we're trying to make the subject y appears twice. What you always want to do in this case is move everything with y's onto one side and move everything without a y onto the other side. Now, you can either do it two ways. You can either move this 4xy there, and then you move that there, like that. Or you could move the 8y to the left and the 3x to the right. It doesn't actually matter. But what I would say, just in terms of it looking nice, I would make sure you don't really have any negatives. So what I mean by that is, if I was to move the 3x over to that side like that, and then move that side, I would have minus 3x minus 20, and then I would have 4xy minus 8y, which is not wrong. You will still get the marks, right? But I don't like dealing with negatives, so I'm going to do it the other way. Yeah. So what I'm going to do is I'm going to move the minus 20 to the left, right, by adding it, and then I'm going to move the 4xy to the right by taking it away. And with that being said, what will happen is that I'll have 3x plus 20, and that will equal 8y minus 4xy, wouldn't it? And then now, once you're here, once you've got the thing and trying to make the subject on the same side, how do you isolate it? How do I only get one of them? Well, you can factor it out, can't you? If I take out a y from there, then it's going to be 8 minus 4x, isn't it? Like that. And then 3x plus 20. And then now, remember, we're trying to make y the subject. What do? This is a factor. You're just going to divide both sides by that factor, aren't you? 8 minus 4x on both sides. Like that. So therefore, the answer is going to be 3x plus 20 over 8 minus 4x is equal to y. Or you could write the other way around. Y is equal to 3x plus 20 over 8 minus 4x. And that's it. That is the question finished. And that will give you 4 marks. Yes, 4 marks. Done. Okay, so question 19 says the acceleration a of an object is given by a is equal to v minus u over t, where v is equal to 45.23 corrected to decimal places, u is equal to 5.12 corrected to decimal places, t is equal to 8.5 corrected to significant figures. By considering bounds, work out the value of a to a suitable degree of accuracy. Show your working clearly and give your reason for your answer. And this is a 5 marker. Now, whenever you see these types of questions, it's a bounds question. But when it says specifically by considering bounds, you need to work out two things. You need to work out the upper and lower bound of whatever it is they ask you to calculate, which in this case is the acceleration, isn't it? And once you get those two, the lower and upper bound, you want to ask yourself, well, what do both of these values round to the same degree of accuracy? Whatever that answer is will be your answer for your acceleration, in this case, the A, right? So I need to work out essentially the lower bound of A and the upper bound. Now, when we look at A, the formula for A, right, we can see that it depends on a couple of things. It depends on V, U, and T. So what I would need to do is ask myself, well, what combination of boundaries am I going to choose for V, U, and T, which will minimize the acceleration in terms of the lower bound, finding the lower bound, and which combination will maximize it, right? The upper bound. So what you always want to do first is get your boundaries for your numbers here, V, U, and T. Now, what I'm going to do is I'm going to write V low here. I'm going to write V up. I'm going to write U low. I'm going to write U up here. So it's going to be upper lower bound. And I'm going to write T low and T up. All right, I need to work out what each of these are. Now, this is very, very simple. All you do here, once you get these, is you're just going to simply put a 0 on. So what I'll do it right here. So for example, 45.2 and then 3, and I put a 0 on there. All you're going to do is add and take 5 from this number to get the upper lower bound. So if I add 5 to 230, that would be 235, isn't it? So 45.235. And if I take 5 away, then it's going to be 45.225, isn't it? And that would be the upper and lower bound of V. So I'm going to write that there. So it's going to be 45.225 like that. And then the upper bound is going to be 45.235. And that's all you need to do to get the boundaries. So this one here, 5.12, if I put a 0 there, that's 120. So the lower bound is going to be 5 take away 120, which is going to be 115. So it's going to be 5.115, 115, and it's going to be 5.125. And that's it. Now this one, correct to two significant figures, it's the same as one decimal place, isn't it? So again, just put a 0 there. Add 5, take 5. So the lower bound, the lower bound, take away 5 is going to be 8.45. And then the upper bound is going to be 8.55. Perfect. So now we've got our upper and lower bounds for each of V, U, and T. Now it's a matter of, well, which combination am I going to choose to then give us the lower bound for A and the maximum, the upper bound? So firstly, let's start with the lower bound, right? So let's write A again. We know that A is equal to V minus U over T. And there's a combination of things here. We've got a subtraction on the numerator, and then we've got the division of T on the denominator. So let's say I wanted to figure out what the lower bound is. The lower bound is, well, I would want, remember, think about, you have a fraction, right? How do you make a fraction as small as possible, right? You'd want the denominator to be as big as possible, right? Because the bigger the number you divide, the smaller the number becomes. So for sure, absolutely, the denominator has to be T upper, like that, right? Which we know is going to be 8.55. That's the first thing. Now, the numerator, if you want, let me actually write this here so it's super clear, right? I don't know, let's say A is equal to, or let me use a different letter. Let's say I said let's say I said it doesn't really matter. Let's just say I said C is equal to X over Y. Like this is just a general thing, right? You can memorize this as well. If I want the lower bound of this, like that, then I would want the denominator to be as big as possible, right? And I'd want the numerator to be as small as possible, wouldn't it? Yeah. And then vice versa. If I wanted the upper bound, like this, I would want the denominator to be as small as possible, and I would want the numerator to be as big as possible, because the numerator is what you multiply by. The bigger the number you multiply by, the bigger the number overall. So these are the two formulas that you can kind of remember. You can just literally memorize these. So going back to what we actually have something extra on the numerator. We don't have one term. We've got a difference. We've got V take away U. But remember, we still want the lower bound, don't we? And that means the numerator has to be as small as possible, right? Now, since we have a subtraction here, what does that actually mean? Well, if I want the numerator to be as small as possible and I'm doing something, take away something else, then surely the thing, right, that I'm taking away should be as big as possible, shouldn't it? Right? So I'm going to write U up here like that, right? And then this thing is adding, isn't it? The V is being added. If I want it to be as small as possible, I'd want this to be, no, sorry. If I wanted, no, I'm correct. If I wanted the numerator to be as small as possible, which I do, the thing I'm adding, I'd want to be as small as possible. So it's going to be V low here, like that. So this is going to be your answer in terms of the combination of boundaries you're going to choose. We want we want A overall to be as small as possible. So it means that we want the numerator to be as small as possible, which means that we're going to do V lower, take away U upper, because we're taking away something as big as possible, and the thing that we're adding is small as possible, and the denominator to be as big as possible. So now it's just a matter of putting this in. So it's going to be 45.225, that's the V low, minus U up, which is 5.125, like that. So that is going to be the calculation for the lower bound of A. So I'll put this into the calculator. Let me just zoom out a bit, just so my face isn't in the way. I think that's okay now. So I'm going to put this into my calculator, see what we get. Calculator. I'll do it here. It's going to be 45.225, whoops, 225, minus 5.125 divided by 8.55. And that is equal to 4.69. And what you want to do is you always want to write every single digit. So I'll just copy it here, like that. So this one here, paste that there. This is going to be A low. This is the lower bound of A. Now, what I want to do is calculate the upper bound of A now. And now we could use this one. So I'm going to write A up here. Now again, we want the fraction to be as big as possible here. So surely we want the numerator to be as big as possible. So the thing that we're adding, which is v, we want it to be as big as possible. So we're going to choose v upper this time, aren't we? And then because we want it to be as big as possible, the thing that we're taking away, we don't want it to be too big. We want it to be, the thing we're taking away, we want it to be as small as possible, right? So I'm going to choose u low like that. So essentially just swapping it over. And then the denominator, remember, we're dividing. The bigger the number you divide by, the smaller the number overall. So surely if I want a to be as big as possible overall, I'm going to choose the lower bound for t, aren't I? So this is my combination now. And now we have the boundaries. We're just going to plug all of this in. So doing that is going to be equal to v upper is 45.235 minus, and then u low, which is 5.115, divided by t low, isn't it? Which is going to be 8.45. And then all I'm going to do is put this into my calculator and see what I get. So putting that in, that's going to be, I'm going to change this to a 4, like that. I'm going to change this to a 1, like that. And I'm going to change this to a 3, aren't I? So I get that there, and I get this number here, don't I? So that is going to be my answer. So I'm going to put that there. Copy that, and then put that there. Okay, so we've done the heavy lifting now. We've got the upper and lower bound of both A, don't we? So if I put that there, if I put this there, okay. So now what I'm going to do is I'm going to write these here. So I'm going to write A low is going to equal 4.69005848. And then A upper is going to equal 4.747928.994. Okay, now the question is, remember, by considering bounds, work out the value of A. So we want an actual answer, right? We need to choose what A will be, and we need to give a reason. Well, we look at this here. You want to ask yourself, as I said at the beginning, what do both of these numbers round to? Now, for example, if I wanted to round it to one significant figure, right, or to the nearest whole number, then they would both be 5, wouldn't they? Right? They would both round to 5. So you could say 5. However, you want to make it as accurate as possible, don't we? So let's try two significant figures or one decimal place, right? Two significant figures. What happens? Well, that will go to 4.7. And so would that one, isn't it? Right? Because the 4 is less than 5, so we keep it the same. So to two significant figures is 4.7. That's more accurate. You want to keep going, right? Now to three significant figures, what happens? What do we get? Well, that one, that is going to be 4.69. Let me write there. All right, 3SF here. That's going to be 4.69. This one, where's that to three significant figures? That is going to be 4.75, isn't it? Right? Let me just double check. Yeah, they are not the same. These are not the same. So we stop at two significant figures. So the answer is going to be 4.7. So now what you're going to say, let me just zoom out because I'm always scared that you guys can't see or some bits are cut off from my face in the camera. So what you're going to say is going to say A is equal to 4.7 as both the upper and lower bound round to 4.7 to two significant figures. And that's it. You have to give your reason at the end to get that final mark. And yeah, that's it. Hopefully, if this comes up, I'm sure it will because they love bounds and it's this type of question. By considering bounds, then yeah, you guys will be fine. But yeah, that's it. That's question 19 finished. Okay, so question 20 says OABC is a trapezium. O to A is equal to A to B is equal to B, O to C is equal to 3B. D is the point on OB such that OD and DB is in the ratio 1 to 2. E is the point on BC such that BE and E to C is in a ratio 2 to 3. Work out the vector D to E in terms of A and B. Give your answer in its simplest form. And this is a 4 marker, isn't it? Yes. So, firstly, D to E, where is that? That's what I would do first. That's what I would mark. D to E is that vector there, isn't it? Right? Now, how do I go from there to there? Well, I could go along D to B, and then once I get to B, I could go along B to E. So what I like to do is actually write the vector that they're asking me to calculate first. So from there, I can say that D to E for sure would be the same as going along D to B, and then once I get to B, I can go along the vector B to E. So for me, the question is a matter of calculating these two vectors, D to B and B to E, adding them together, and that's your answer. Now, how do we go about getting those vectors? Let's look at the information about the ratios. So they told us that D is the point on OB such that OD and DB is in the ratio 1 to 2. So where is that? OD is there, like that, and then DB is there. And this is in the ratio 1 to 2. So remember, think of it as parts, isn't it, right? We're saying that we've got 1 to 2 parts. So we have 3 parts in total. The blue part is going to be 1 out of those total 3. So this is going to be 1/3 of the way. And then this one in yellow is going to be 2/3 of the way, isn't it? So just with that information, that tells me that D to B is just 2/3 of this entire line. So I'm going to write that actually. I'm going to say D to B based on that is actually equal to just 2 out of 3 parts of the entire line, which is the vector O to B. The vector O to B. So we have that there. We can calculate that, which I will do in a second, but I'm just going to leave that for now, right? So next part is looking at B to E. Well, look at the ratio. The second one, E is the point on BC such that BE and EC is in the ratio 2 to 3. So again, we can do the same thing. So I'm going to say this is 2 parts here, like that. That's going to be 2 parts. And then this part here, what color should I use? I use this one. This is going to be 3 parts, isn't it? Like that, right? So how many parts are there in total? There are 5. 2 plus 3 is 5. So that means that this green part is 2/5 of the way. And then this part here is 3/5 of the way, isn't it? Like that. And then from there, what I can say is that, well, the vector in green, B to E, which is what we want, right? B to E is just equal to 2/5 of the way of B to C, isn't it? Like that. So now I can actually update this, isn't it? I can say, remember what we're looking for? We're looking for D to E, which is DB plus BE, and we've got those vectors in terms of OB and BC. So what I'm going to do now is say that D to E, just based on that, is going to equal D to B, which we know is 2/3 of O to B, plus B to E, which is 2/5 of B to C. So now we just need to calculate what O to B is and what B to C is, put them in, and then simplify. So O to B, what is that equal to? Well, O is here, like there, and B is right there. How do I go from O to B? Well, surely I could go along O to A. I can go along there, that's A. And then once I get to A, I can go along B. It's the same direction. This is just quite clearly A plus B, isn't it? Like that. Let me actually make this a bit neater, sorry. So I'm going to say O to B, just on that, it's going to equal A plus B. For sure. So we've got O to B. What's B to C? Well, B to C, right? B to C is over here. B is over here, sorry. And C is over there. Surely I could go round, couldn't I? So I'm going to say B to C just by looking at the diagram is going to be the same as going from B to A. So, all right, B to A. And then we can add on A to O. And then once we get to O, we can just go along O to C. Right? Now, what are these vectors? B to A is just the opposite direction of A to B, isn't it? Right? So that is going to be a minus B. And then plus A to O, again, is the same thing going in opposite direction of O to A. It's going to be a minus A. And then plus O to C, that's the only one going in the same direction. It's going to be 3B, like that. So this there is just minus B, plus or minus makes a minus, minus A plus 3B. And then that there, tidying that up, I've got a minus B plus a 3B. That's a 2B. I'm taking away A. Right? So I now know what the vector B to C is. It's 2B minus A. And I now have the vector O to B, which is A plus B. So now we have everything we need to answer the question. We can just replace those, can't we? So I'm going to do that here. We know that O to B is A plus B. So it's going to be 2/3 of A plus B plus 2/5 of B to C, which we have figured out to be 2B minus A, isn't it? So I can put that there. I remember this is the vector D to E, isn't it? Now it says give it in terms of A and B. It is in terms of A and B now. We just need to simplify. So let's expand, right? And see what we get. So expanding that is going to be 2/3 A plus 2/3 B, like that. And then plus, and then 2/5 times 2. Remember, it's a calculator paper, you can just put this in, but this is just 4/5. That's 4/5 B. And then 2/5 times a minus A is going to just be minus 2/5 A, isn't it? Like that. And then now we can just group the like terms together and collect them. So what I'm going to do, I'm going to just reorder it. 2/3 A, and then minus 2/5 A, like that. So that's the A's. And then we've got 2/3 B plus 4/5 B. So all I want to do now to simplify this is just essentially just put this into my calculator. 2/3 take away 2/5. That will give me the coefficient for A. So 2/3 minus 2/5. That is equal to 4/15. So it's going to be 4/15 A, right? And then this one, I know it's going to be positive because they're both being added. It's going to be plus. Whoops, that doesn't look nice. We'll do it again. So plus. And then I'm going to do 2/3 plus 4/5. 2/3 plus 4/5. And that gives me 22/15. B. So therefore, the vector, let's start, the vector D to E is equal to 4/15 A plus 22/15 B. And that's it. And I'll give you the 4 marks. Okay, so question 21, the final question. It says the line L is a tangent to the circle x squared plus y squared is equal to 25 at the point A. A is the point 34. The line L crosses the x-axis at the point P. Work out the area of triangle OAP, and this is a 5 marker. Okay, now this one here, very, very tricky. It hasn't come up in a while, right? In terms of finding an area, but circle questions do come up. So how do we go about doing this? First thing you want to do is visualize the problem. So I'm going to get a coordinate axes going. Right. Now, couple of things here. You need to have knowledge of equations of circles, right? The general formula for the equation of a circle, right, is x squared plus y squared is equal to r squared, right? And for GCSE, this just means that your center is at 0, 0, and your radius is equal to r, right? So in our case, x squared plus y squared is 25. That means that r squared is 25, isn't it? Square root in that is going to be r equals 5. So we have a circle here where the center is at the origin, 0, 0, and the radius is 5, right? So it's going to look something like that maybe. Let me just, something like that, right? I think that's okay. No, actually, let me just, this is a bit towards, let me just, I'm just trying to be a bit of a perfectionist here. 1 second, guys. So I'm going to put that, I think that's better. Yeah, that's better. That's fine. Okay, perfect. So what do we need to do? Well, let's plug in, let's annotate this diagram. So obviously this is our y-axis, that's our x-axis. And they told us that A is the point 34 and it's a tangent. Remember, what is a tangent? You need to remember these definitions. A tangent is a line which just touches your circle, right? So where would the point 34 be approximately? So remember, we know that the radius is 5. So let's just say 5 is over here, like that. That would be minus 5, like that. So I put 15. Be minus 5, like that. So the point 34, well, 3 approximately, let's just say is around there. 4 would be here, isn't it? Right? So the point 34 is on your circle. So I'm going to put a 4 there. So this is the point A, which is 3, 4. Okay, now the line L is a tangent. If it's a tangent and it just skims it, then, well, what way would the line be going? Surely it would have to be like this, essentially. Something like that. Yeah, that looks perfect, right? That's going to be my line L. I'm going to call this line L. Okay. Now, what do we know? It says that the line L crosses the x-axis at the point P. Well, the line L crosses the x-axis right here from our diagram, so we can label this point P. And we need to find the area of OAP. And obviously O is the origin, isn't it? So I'm going to put O there, right? And then if I connect this and that, so I'm going to connect O to A, like that, then they're actually just asking me to work out the area of that triangle. So what I would do is I'm going to draw that triangle again. I'm going to do it here. So it looks essentially like that, right? Now this is O, this is A, this is P. We're trying to find the area of a triangle. Remember, the formula is just half times base times height. So if I could figure out what that height is, the perpendicular height, and this base, right? Then we're in business, aren't we? Right? So I'm going to just say area is equal to half times the base times the height. Okay. Now, looking at the diagram, are we able to calculate any of these straight away, right? We actually can, because if you think about it, if I do this here, like that, this height here, right, just so happens to be the y coordinate of that point A, isn't it? Right? That is going to be a 4 for sure. It's just the y coordinate of the point A. So I'm going to just say h is equal to 4 here, right? Now, the question is, what is the base? What is that distance O to P? Well, if I knew what this x coordinate was, for example, let's just say x was equal to 10, for example. It's not, right? Or we don't know. It could be. It couldn't be. Let's just say x was 10. Well, to go from O to P, we're just going across by 10 units. So the base would be 10. So what we need to do is calculate this value of x at P, right? The question is, what is that x coordinate of P? Once I know that, then that will just tell me what the base is. Now, how do we calculate that? Well, they gave us a bit of information. The line L crosses the x-axis at the point P. So it has to do with the line L. And to be able to answer this question, we need to find out what the line L is. Because if we know what the line L is, then we can figure out where it crosses the x-axis. Because that is just going to be, and this is another thing as well, when it crosses the x-axis, what is your y coordinate at that point? Your y coordinate is 0, isn't it? So if I had the equation of line L, I can just plug in 0 and I can solve for x, and that will give me that point P. So how do I do that? Well, we've got a couple of things here. This topic here, specifically equations of circles at the end of the paper, is a combination of a couple of topics. It's a combination of obviously circles, equation of circles, and it's also circle theorems as well as equation of a line. And I'll tell you why. The reason why is because if I want to calculate this line L here, well, every single line has a general formula, right? It's y equals mx plus c. So I'm going to write y equals mx plus c here. And our job is to calculate what m and c both are. Now, how do I go about doing that? Well, I need the gradient, which is m, and the y-intercept. Now, am I able to figure out anything here? You absolutely can. And this is why I say it's a part of circle theorems too. What do we call this distance here from O to A? Well, it goes from the center of the circle to the circumference. This is the radius, isn't it? Right? Now, remember the connection between a radius and a tangent. Remember, this is a tangent. That is a tangent. And that is a radius. I've put R for radius, right? They meet at right angles, don't they? Yeah, that is a circle theorem. So the reason why that's helpful is because if I could calculate the gradient of the green line, the radius, then that would allow me to calculate the gradient of the blue line. Because remember, gradients are the negative reciprocal of one another. They are perpendicular. And what I'll do is I'll put a little graphic about right now so you can see what I'm talking about. Okay, so doing that, what am I going to do? I need to calculate the gradient of that green line, and I can do so. I'm going to do it here. I'm going to put O here. I'm going to put A here, right? And I know that this is 3, 4. I know this is 0, 0. So I can calculate the gradient of that line, can't I? So let me just do it like that. And quite clearly, you could just do change in y over change in x, can't you? Let me get rid of this 3 there. You can just do change in y over change in x, which is going to be like that. It goes across by 3 and it goes up by 4, doesn't it? So the gradient is just going to be 4/3. But what you could do is you could just do change in y over change in x, which is going to be 4 take away 0 over 3 take away 0, right? Which is still 4/3. So we know the gradient of this radius. It's 4 over 3. I'm going to write m is equal to 4 over 3, like that. Now, since the gradient of this one, I'll do it in this color here. This is 4 over 3. The gradient of this tangent line, which is perpendicular, is going to be the negative reciprocal, which is going to be negative, flip it over, 3/4. So I now know the gradient of the tangent. I can update the equation of line L. Remember, the key is to figure out what line L is, right? Now I can say, I write line L here. Line L, it's going to be y is equal to minus 3/4 x plus c. Now, remember, we're trying to figure out what the equation of the line L is. We have the gradient. We now need to figure out the y-intercept. And it's the exact same thing with these types of questions, this specific type of question here. You have your line L. You find the negative reciprocal, right, from the radius. The gradient is minus 3/4. How do we find c? You need a point that passes through your line. Do we have that? We absolutely do. The point A is tangent, isn't it, right? It goes through the line in blue, and obviously it touches the circle there as well. So that point 3, 4, we're going to substitute into our line L because we can see quite clearly it passes through it, and that would allow us to calculate what C must be. So doing that, I'm going to say put 3, 4 into L. Yep, into line L. And that would be 4 is equal to minus 3/4, and then x is 3 plus c. And then that way you have 4 is equal to, remember, you can use your calculator here. That's just going to be minus 9/4 plus c. And then I can add that on. So 4 plus 9 over 4 is going to equal c. And then you can just put this in your calculator. 16 over 4 is going to be 25, but I'll put it in anyway just to be complete. 4 plus 9/4 is going to be 25 over 4. So C is going to equal 25 over 4. So now I have the full equation for line L. So I'm going to say y is equal to minus 3/4 x plus 25 over 4. That is line L. Now, how is that helpful? Well, we know that the y-intercept is 25 over 4, so we may as well put that in. Now, remember what we were trying to do. We need to figure out the x coordinate of the point P, because once I figure out what that is, that will give me the base. So what was the whole point of us calculating the equation of the line L? It was so that we can now substitute y equals 0 into it to give us x, right? Because remember, at the point P, when you're along the x-axis, you're not going up or down. Y is 0 there. So I can plug in y equals 0 into the line L, and that will allow me to calculate what x is, right? So that's what I'm going to do next. So how much room do I have? I don't have any room. Have I got another page? I do. I do. You know what I'll do? I'll just do it here. So I'm going to plug in y equals 0 to find x, like that, right? So that will give me 0 is equal to minus 3/4 x plus 25 over 4. And then that way, what I'm going to do is I'll do it here. It's going to be 3/4 x. If I move that from right to left, it's going to be 3/4 x is equal to 25 over 4. And then how do we get x here? Well, they're both dividing by 4. You can actually just times both sides by 4, can't you, to cancel them? So 3x is going to equal 25. So times by 4 on both sides, like that. And then now we can divide by 3. So x is equal to 25 thirds, isn't it? Like that. And that there is the value of x. So that question mark, I can actually change to 25 over 3. That's a bit of a messy diagram. But essentially what we have here, I'll do it again, just so it's super clear. I'm going to draw the triangle one more time. So it's going to be like this here. And what we've calculated, remember, this was the 0.34. That told us that the height was 4, right? And this point here was 0, 0. This is x equals 0. And this point here, we figured out, which is point P, is x equals 25 over 3. So what is the base? Well, the base is just 25 thirds, isn't it? It's just 25 thirds, right? This is the point O. This is the point A. This is the point P. The question asks us to work out the area of triangle OAP. So therefore, the answer is literally just going to be, I'll do it here, area is going to equal 1/2 times the base, which is 25 over 3, times the height, which is 4. And then doing that, that is just literally going to be times all of the numerators together, put that over 1. That's going to be 100 over 6, right? Which is 50 over 3. And obviously you could put this into your calculator as well. So yeah, that's it. That's the answer. And that is the entire of paper 3 finished. So I'm hoping, fingers crossed, that this comes up, because I think it's a good question. And if it does come up, it will definitely be probably the last question in the exam. So yeah, that's pretty much it. That is paper 3 finished. Hey guys, Daniel here. So yeah, that's the paper, and that concludes the series of predicted papers. And wow, can't believe I got this done. It's the first time ever doing something like this. So it's been a lot of fun. It's been a lot of hard work, but I'm happy to say that it's done now. But yeah, more importantly though, I'm hoping that this paper has helped you with your revision for paper 3, and it's put you in a better position. Any questions that you may have found tricky, I'm hoping that the walkthrough this video has clarified things for you. And again, I just want to just say I'm proud of every single one of you. You're nearly there. And yeah, best of luck on the 11th of June, and best of luck on all of the remaining of your GCSEs as well. So yeah, nearly there, guys. June is nearly done. You're gonna have the summer to relax. So keep going, guys. You're doing very, very well. And also, if you found these videos helpful, then yeah, it's always appreciated if you like, comment, subscribe, share with your friends, share with anyone that you that you think will find these videos helpful. But again, good luck for paper 3. I know you guys are all going to smash it. Let me know how it goes. And yeah, see you guys soon. Take care. Bye-bye.